Okay, so today I am going to discuss another three problems came in this CSIR NET July exam, and those three problems are from classical mechanics. So let's look at the first problem. So the problem says a particle of unit mass and unit charge is moving in a magnetic field B as a function of r, that is B naught r vector divided by r cube, where B naught is a constant, over a region far away from the origin, and capital L is the instantaneous angular momentum. Then you have to calculate what is dl by dt. Okay, so this is actually a doable problem, and some of you may get confused with that b, the expression of b is a function of r. So let's look at the solution. So we know that when a particle with some charge moves in a magnetic field, the velocity vector is always perpendicular to the radial vector. So magnetic field will push the particle in such a direction that it will always move perpendicular to the direction of magnet radial direction. So this is the governing equation which tells us the centrifugal force is equal to the magnetic force. So mv square by r is equal to qb. Now b is a function of r. So you can calculate v is qbr by m. Now put q is equal to 1 and m is equal to 1. You will get v is equal to b and r. So you have the expression for b in the question, that is b naught r vector by r cube. So when you multiply this by r, you get that b naught r vector divided by r square. This is v. So v as a function of r is equal to b naught r vector divided by r square. Now, what is L? L is MVR. Now, keep one thing in mind, that why I am writing this as MVR. This should be MR cross V, right? So, MVR sine theta, actually, the angle between R and V. So remember that, as I already mentioned, when a particle moves in a magnetic field, the magnetic field pushes the particle in such a direction that it will always, the velocity vector is always perpendicular to the radial direction. So don't get confused that why here b is the function of r. So how should be the velocity vector? How should be the radius vector? Don't confuse with that. It is straightforward thing that velocity vector is always perpendicular to the radial vector when it is moving in a magnetic field. Its velocity is a function of r now. Radius, velocity, everything keep changes with distance, time, everything. But it's still the direction of velocity vector is still perpendicular to the radial vector always. So keep this thing in mind and don't get confused with that. So here L is MVR, sin theta is 1. So you have VR as a function of R and multiplied by R. So your final expression for L will look like B naught R vector divided by R. So when you do dl by dt, that is B naught ddt of R vector by R. So option 3 will be the correct option for this question. So you, some of you may get confused with this expression for VR, but don't take any confusion. V is always perpendicular to the radial direction. Keep this thing in mind. Okay, so now let's do a second problem. So here is a simple harmonic oscillator Lagrangian, that is q dot square by 2 minus half q square, and h is the Hamiltonian, and there is a quantity given a as a function of p and q, normal momentum and position coordinate, that is 1 by root 2 p plus iq. So you have to calculate what is the Poisson bracket of a and h. Okay, so this is the Lagrangian given. So first you have to calculate what is the Hamiltonian, and for Hamiltonian you need what is the momentum. So momentum is simply P is equal to del L del Q dot. So that is equal to Q dot. Now you can write the formula for H. H is equal to sum over Pi Qi dot minus L. So finally you can get that H is P square plus Q square by 2. Now, what is Poisson bracket of A and H? You put the factor root 2 outside. It is P plus IQ, and the H is P square plus Q square by 2. So you can pull again the 2 factor outside, that is 1 by 2 root 2, and you have the 4 Poisson bracket, P with P squared, P with Q squared, iota into Q with P squared plus iota into Q with Q squared. So these 4 Poisson brackets you have to evaluate. Now the formula for Poisson brackets, you may remember that this is del A del Qi into del B del Pi minus del A del Pi into del B del Qi. So why I am writing this summation over Q and Pi? Suppose you have a problem where you have two normalized coordinates, that x and px and y and py. So you have to sum this over, that you have to first put x and px and x. Then you have to sum that y and py and y. So you have to do this for both the coordinates xpx and ypy. So keep that thing in mind. So here you have only one normalized coordinates, that is q and p. So if you have multiple coordinates, then you have to do it multiple times. So yeah. So now p and p square is surely 0 because there is no q involved here. P and Q square, the first term is 0 from this expression, and the second term is minus 1 into 2Q. So if you differentiate Q square with Q, you get 2Q, and P with P give you 1. So this is minus 2Q. And similarly, you can do the other two calculations very easily. Poisson bracket of Q and Q square is 2P, and Poisson bracket of Q and Q square is 0 again. This is similar like what you do in quantum mechanics actually. This is simple. I mean exactly similar. So the Poisson bracket of A and H is equal to 1 by 2 root 2 bracket. In bracket there is minus 2Q plus 2IP. So 1 by root 2 into IP minus Q. If you pull this iota outside from the bracket, you will get I by root 2 into P plus IQ. So that is equal to IA. So the option 1 will be the correct for this question. Now you have a third problem. These are all 5 marks question actually, and there is a huge part of classical mechanics in this CSIR net exam. So this is the last question. A linear molecule is modeled as two atoms with equal mass m placed at coordinate x1 and x2, connected by a spring with spring constant k. Molecule is moving in an additional external potential, that is half m omega naught square into x1 square plus x2 square. So if one frequency of vibration is omega naught, then what is the other one? So this is the problem, and this is actually a simple problem. So when you have a two mass spring system, if you give a little displacement x2 to the first mass and x1 to the second mass, then your spring potential energy will be k by 2 into x2 minus x1 and whole square. This is the change in length of the spring. Now you have the total potential energy Vt is equal to Vas, that is spring potential energy, plus Va, the additional potential energy. So this potential energy, that is m omega naught square by 2 into x1 square plus x2 square, this is additional. This is some external thing which you are pushing to these particles. So this is the spring potential energy plus this is the additional potential energy, and now you can collect the terms containing x1 square, that is k by 2 plus m omega naught square by 2. The tar coefficients of x2 square will be k by 2 plus m omega naught square by 2, and the coefficient of x1 is 2 is minus k. And of course the kinetic energy is simple, that is m by 2 into x1 dot square plus x2 dot square. Now you can find the normal modes by usual technique, that is determinant of v minus omega square t is 0. So you can calculate the matrix for Vij, that is del to v del x1 square, del to v del x1 del x2, this kind of terms. So this is the V matrix, and the Tij matrix is similar, that is diagonal, and diagonal terms is M. So you can simply do this determinant calculation, and doing a little bit of algebra, you can finally find that omega is 1 omega is omega naught as it is given in the question, and another omega is root under omega naught plus 2k by m. So sorry, I missed the options, but this is the right option. That is root under omega naught plus 2k by m. Will be the another correct option. Okay, so thank you. If will be any doubt and any suggestions, please let us know in the comment box. And I am giving also a link of WhatsApp channel in my description. If you are interested, you can join, and we will discuss more advanced problems in various topics. As I already uh, given a link of Physics Galaxy channel in my comment section. You can also watch this. This is a very advanced problem of classical mechanics, and it may help you. You can watch this video. I will paste the link in my comment section. So yeah, thank you.